Hey there. In this video, I just want to quickly go over like linked list structures. So a linked list is a little bit more difficult than array because it involves nodes and pointers. Arrays are super easy to access data, but linked lists, it's a little bit different. So with a linked list, this value has a pointer to the next node, and then this node has a pointer to the next value as well as a value inside of here. So as an example, I'm just going to print head real quick. Print head. So you'll kind of be able to see the structure from this print statement. It's also defined up here. There's a value and then there's a next value. So here, this is what the head contains. It contains all these pointers and references to each value. So one knows that there's a next node and there's a value somewhere in here. But you can't just jump across. You have to follow the pointer structure. So I'm going to do a quick Ooga booga situation for someone that's more familiar with arrays and is new to linked lists. It's kind of a way to wrap your head around it in two different ways. And then I'll show you the way to do it like efficiently, where you can actually like reverse the pointers. It's kind of hard to wrap your head around, but it's a lot cleaner. So for this, you never want to iterate through the head. The head is just a reference. So it's always good to create a current and set that to head because we don't want to be touching the head of the list. And then also I'm just going to make a quick array. Just have that be empty. So while current, so like while I'm iterating through here, what I can do is ar.append current.val. So this is going to get that value and add it to my array structure. Just so then we can use it, we can reverse it and spit out an output. And then to move next in the list, I do current equals current.next. This is a little confusing, but this is just saying, hey, I'm on a node. Is there another one? Do it if I can. So current is now going to be set to the next one in the list. So from here, we have our list. So I'm just going to print AR. Probably going to break because I'm not returning anything, but so yeah, now I have this list. And what I can do now is I can reverse it. So I'm going to do AR equals, and let's bring up the slicing tool again because it's always helpful. -1, awesome. And then I'm just going to print AR. So now this will be the reverse of this. It's not technically the way that you should be doing it, but it's just a way to think about it. So now I have my new reverse list. So now I can set, we need to go back through here and we have to actually return a linked list. So because we have that head pointer, it still knows that this structure exists because we use current to just rip through it, but head still knows like what a list is. But in this problem, we have to return as a list and return the reverse list. So I couldn't just return the array. This would break if I try. So like return AR. Because they're not the same type of data structure, it's not going to work. So even though it looks the same, it's not. So from here, what I would do is I could do, so let's do new current. So let's just, we're just going to re-reference this. So new current equals head. And then what I want to do is have a index value to reference this array. So index equals 0. And then we can just rip right back through it. So while new current, the new current dot val is going to equal the array at the index position. So this will be 0, then 1, 2, 3, 4, 5. And this will increment. And like I said, with while loops, they can be dangerous. So you got to make sure to increment it. So index plus equals 1. But we also have to account for moving through the list. So new current equals new current next. So pretty simple there. So now for each one, it's going to go item 1. That's going to be a 5. Move next, 4, 3, 2, and so on. So now if I return this, so return head. So head still has the reference to this entire list, and that's what we want. I run that. And got it first try. That's awesome. So yeah, now it is a linked list, and it knows what's going on. So if I would print out head, All right, yeah. So if you print out the head here, if I run this, this will show that it is in fact a linked list structure. So this is what I'm returning. It's the exact same thing as what I had printed up here before when it was the node values. So you can't return an array as a linked list. If a question has like a specific return type, you just have to follow it. There's nothing you can do. You have to follow the protocols for the question that you're answering. So hope that was useful. That was the Ooga booga approach. So let's try to do another one real quick about a more efficient one. So you don't want to be iterating through values more than you have to. So like the previous example was like putting all of these into an array and then rerunning it to set everything correctly. So it works, but it's not efficient. So with this new approach, what we're going to be doing is flipping these pointers around, and then we only have to iterate through this linked list one time. So much more efficient. And don't get discouraged. Linked lists are pointer flipping in nodes is a little bit hard to wrap your head around, but just keep working at it. I'll just run through this example quick just as a reference. So I'm gonna set current to head just like before, but I'm gonna add this new placeholder called previous, and I'm gonna set that to none. Previous equals none. All right, so we're gonna rip through the linked list again. So while current, and then this is where it gets a little tricky. So we're going to set a temp variable so we can reassign it, so we can allow this program to flip the pointer around. So I'm going to call this temp node. I'm set that to current.net next. This next one I'm going to do current dot next equals previous. And then here, I'm going to set previous equals current, and current equals temp node. I'll explain this in just a second. So I'm going to return previous. So if I run this, awesome. So yeah, this works as well. So basically what's going on, I'll do my best to explain this. So like the temp node equals current.next. So we're setting this placeholder to 2 because it's the next node in the chain. And then current.next equals previous. So what we're saying is this next node is going to get assigned now. So previous is no longer none. We don't really need to care about the one because we just need to flip the pointer to point back at one, and we do this throughout the chain. And then with previous equals current, that's saying previous is now flipped around and it's addressing this one, and then the current is now the temp node. So it's going to be the next value in the chain. So that means like I move to the 2, I still have reference to this 1 over here, and then I flip that pointer around, and then throughout the chain, it's going to do the same thing. It's going to move to the next one. So now I'm at 2, and then it's going to point to 3, move over here, and then just keep flipping this pointer until the end of the linked list. If you want me to get more in depth with this, I can do my best, but it does take a little bit of just practice and understanding on how pointers and nodes work. It is a bit difficult, and it's just your brain just doesn't. For my brain at the beginning, I just couldn't really comprehend this. But after just a little bit of practice, it became super comfortable and easy to do. And then we have to return previous because now it's going this way, and it's the reference to the node that's coming back. So once we get to 5, we're saying, hey, this is the new head, kind of like what we returned. And then it's just going to have all these arrows pointing back down. So wherever it starts and where it's pointing, it's going to be the head of the list. So hope that was useful. Good luck on your coding journey and have fun learning, and hope you have a great day. Take care. Bye-bye.